All right, hello folks. This is Mike coming back at you with a continuation of our previous video. In the previous video, we talked about what the heck a rational expression is, and we talked about the concept of a rational expression being undefined at some x values, and we talked about how we can find those particular x values. And then we finished up with the fundamental property of rational expressions, which again is nothing new. We've been using this property all throughout the course up until this point, but now we're just going to also bring variables and factors containing variables into the mix. And just as a quick recap, this property says that we can divide out common factors that occur in the top and bottom of the rational expression, and now those factors can contain variables. And when we do this, we're getting our rational expression in what we call lowest terms. So to write a rational expression in lowest terms, you just have to factor the numerator completely and the denominator completely, and then you have to divide and cancel out all common factors that happen in the top and in the bottom. So let's write each rational expression in lowest terms. We'll do some of the sample problems below here. Starting off easy, just with a fraction. You know, this is something that we've been doing all throughout the course, but it's something that we're used to. It's something that we're more comfortable with. Let's think of factors of 15 and 35, and maybe there's a common factor in there that we can cancel out. Well, 15 we know is 3 times 5, and 35 we know is 7 times 5. So the top has that factor of 5, the bottom has a factor of 5 there. So if we divide and cancel those out, I'm just left with 3 over 7. And that's in lowest terms. We can't factor this any further. We can't break this down anymore. These next two samples here, things that we have seen plenty of, especially over the last couple chapters. Dividing things where there's just one term. That is something that we're used to. This may be something a little bit different, so we'll still work with it. Negative 16 times x squared divided by 8 times x to the fourth. Divide the numbers in front. Negative 16 divided by 8 is negative 2, and x squared divided by x to the fourth, we are dividing powers of x, so we will subtract those powers. So it's x to the 2 minus 4, or x to the negative 2. But again, we typically like to write these so that there's no negative exponents. So I have to take this x to the minus 2, move it to the bottom of my fraction, and then that exponent becomes positive. So I have negative 2 divided by a positive x, or divided by an x squared. That exponent of 2 is now positive. But here's where things perhaps get a little bit more different. This is what we really talk about when we talk about simplifying rational expressions. X squared minus 9 divided by x plus 3. The top here, we see an x squared term. We just see a constant. Thinking back to chapter 5, specifically section 5.4, if we're seeing the difference of an x squared and a constant, then perhaps we're thinking, okay, maybe difference of two perfect squares. Well, 9 is indeed a perfect square. This top right here, that whole top, is equal to x squared minus 3 squared. 3 squared gives me 9. So this is a difference of two perfect squares. And we know that when we factor a difference of two perfect squares, we get two binomials. The first term is the same, and that term is the first thing that we're squaring, x. The second term is the same, and it's the second thing we're squaring, the 3. And then the only thing that differs is the sign that we put. Here there's a minus, here there's a plus. And this is all over x plus 3. Okay, well now we look. We have an x plus 3 on the bottom, clearly. We see we have a factor of x plus 3 on the top. So the x plus 3 on the top and the x plus 3 on the bottom will divide out or cancel out. So what are we left with? We're just left with the x minus 3 that we had on top. So we would just write x minus 3. Moving on to the next one here. Y squared minus 5y minus 14 all over y squared plus y minus 2. Let's factor each of these trinomials and specifically these quadratics. Let's factor each of these separately and let's see if there's a common factor on the bottom and top. So y squared minus 5y minus 14. I need two factors, two numbers that will multiply to negative 14 and add up to a negative 5. If you do a little bit of thinking, perhaps a little bit of trying some number combinations, eventually you'll land on negative 7 and positive 2. So when we factor this, it's nice because it's just y squared. There's not a number in front of our y squared. So again, we're going to have two binomials. First terms are just going to be my variable, y. And then we had minus 7 and plus 2. Okay, let's do the same kind of thing with the bottom. Let's factor that bottom and see what we have. Again, it's just y squared, so we're going to have, once again, two binomials, and the first terms are just going to be y's. I need two numbers now that multiply to negative 2 and add up to positive 1. This is a little bit nicer. There's fewer sort of possible options to choose from, and the option that's going to work is negative 2 and positive 1. So minus 2 plus 1. Oh, nope. I'm sorry. Switch the location of the minus sign there. It's positive 2 and negative 1. Correction. So it's y plus 2, y minus 1. So now that we have it right, now we look and see, is there a factor that's happening on both the top and the bottom? Well, on the top we have a factor of y plus 2, and on the bottom we have a factor of y plus 2 as well. So we can divide and cancel out that common factor, and what are we left with? Y minus 7 over y minus 1. We can't cancel these things out because they're not just y's. We have y minus something else. If you're adding or subtracting something else, then that doesn't let you just cancel that thing out. You cannot just cancel out these y's and then say that it's minus 7 over minus 1. You cannot do that because we have something else tied onto it. Because we are adding or because we are subtracting something to or from those y's, we have to leave these as one whole thing. All right, going down to the bottom here, z squared plus 2z plus 1 divided by 5z plus 5. Okay, so let's factor the top. Again, it's a nice quadratic, just z squared. So the first terms in each of my two binomials will be z's. I need two numbers that multiply to positive 1 and add up to positive 2. Shouldn't take you too long to figure out that those numbers are positive 1 and positive 1. So plus 1 and plus 1. All right, let's see if we can do anything with the bottom here. I have 5z plus 5. Well, I look at each of these terms, and I see that each term has a common factor of 5. So I can pull that factor of 5 out, and what am I left over with? Well, I'm left over then with z plus 1. And now here we can see that we have a common factor between the top and bottom that we can divide and cancel out. On the top, I have two z plus 1s. On the bottom, I have one z plus 1. So I can divide and cancel out the one z plus 1 on the bottom with one of my z plus 1s on top. And I'm still left with, on the top, z plus 1, and on the bottom, 5. And last one here for this video. X cubed plus 9x squared plus 20x divided by x to the 4th plus 8x cubed plus 16x squared. This is probably the most type of challenging problem you would see from me. Let's try and factor these things out completely. I look at the top here. I'm going to start with the top. I see that each of the terms has at least one x to it. Here's an x cubed, here's an x squared, and then here's just an x. Obviously, the smallest exponent on the variable between these three terms is the 1, so I can pull one x out of each of these three terms. And when I do that, I'm left with x squared plus 9x plus 20. Looking at the bottom here, I see I have an x to the 4th, I have an x cubed, and I have an x squared. Each of these terms contains at least two x's, because the smallest exponent on the variable is the 2 here. So I can pull an x squared out of each of these terms. So that gives me x squared times, and when I pull the x squared out, I'm left with x squared plus 8x plus 16. Now, here I have a quadratic, here I have a quadratic. Let's see if I can break these things down anymore. So on the top, I have x times x squared plus 9x plus 20. Again, two binomials, x and x. I need numbers that multiply to 20 and add to 9. If you think of factors of 20, the right combination you're looking for is plus 4 and plus 5. On the bottom, again, another quadratic, x and x. I need two numbers that multiply to 16 and add to positive 8. Those two numbers are plus 4 and plus 4. So, Now let's try to simplify this thing. I see I have a factor of x plus 4 on the top, and I have a factor of x plus 4 on the bottom. So I can cancel those out. Also, this x squared here, if you want, you could rewrite as x times x. And now you can see you have one x on top that can divide and cancel out with one of the x's on the bottom. So that x is gone. I'll say that x is gone. So now what are we left over with? Well, on the top we have x plus 5. On the bottom we have x times x plus 4. And now we see there's no common factors. The x plus 5, the x plus 4, and the x are all different factors. Cannot cancel those out any further in any way, shape, or form. Last thing I want to touch on this video before we end it here, we have a special simplification that we can make under certain circumstances. If the numerator and the denominator of a rational expression are opposites, then the rational expression equals -1. And when I say opposites, I mean that the terms are just switched in their place. You still have the same sign that's in the middle, but the terms are just switched. So here, 2 minus x over x minus 2. Same sign in the middle and the same terms between the top and bottom, but we just switched the places to get the other piece. Here, 17 minus 3x divided by 3x minus 17. 2x minus x squared divided by x squared minus 2x. Once again, we're just switching the places of these terms, and when you do that, that simplifies to a -1. But we can only do this when there are two terms involved. We can't do this when there's 3 terms on the top and 3 terms on the bottom. Only has to be 2 terms in the bottom and the top in order to be able to do this. So guys, that concludes our video on section 6.1. In the next video, we will move on to section 6.2 and talk about multiplying and dividing rational expressions. If you have questions or comments, please be sure to reach out to me, guys. Emails, voice messages on my phone. Stop into my office hours. Stop into my tutoring hours. You know how to get a hold of me and where to find me. Until the next video, take it easy, guys.